Hello. So here we have the Lagrangian for a harmonic oscillator. And in this video we're going to derive the Hamiltonian and we're going to look at the Hamilton's equations to derive Hooke's law. So we know that momentum for the Euler-Lagrange equation, momentum is equal to the partial derivative of L, which is a Lagrangian, with respect to velocity x dot, which is simply mx dot. Okay, because we use the power rule for derivatives, we bring the 2 down, that cancels with the 2, so we simply get mx dot for our Lagrangian. Okay, so we know that the Hamiltonian h is equal to x dot times your momentum minus your Lagrangian. Okay, so this is going to equal x dot times p minus m over 2 x dot squared minus k over 2 x squared, like so. Okay, so let's put that in brackets like so. So x dot p minus, you could say, your momentum times x dot, so it's literally a half m over 2 x dot squared. Does that make sense? Because we have x dot p, we have a half x dot p. So we're simply going to get a half x dot p back. So our Hamiltonian in this case is simply going to be, the minus makes that a plus. So we're going to get m over 2 x dot squared plus k over 2 x squared. Okay? So we can replace the x dot with m over 2, our momentum divided by our mass. Okay, so x dot is equal to p divided by m. So therefore we get h is equaling p squared over 2m plus k over 2x squared. Okay, so now we can focus on the Hamilton's equations. Now we've got our Hamiltonian. So Hamilton's equations go like this. We have x dot is equaling the partial of h with respect to p. Okay, so what's this going to equal? If we look at our Hamiltonian, we differentiate h with respect to p. You can see it's going to equal simply p over m. Okay, that 2 and that 2 will cancel when you do the derivative. Our second Hamilton equation is our momentum. So the rate of change of momentum. This is going to equal minus dh by dx. Okay, so what's this equal to? Differentiate our Hamiltonian with respect to x. We have our 2. The 2 cancels with that 2, so we simply get minus kx. As you can see, we know that the rate of change of momentum is your force, so therefore we get Hooke's law, which says force is equal to minus kx. Okay, simply using the Hamilton's equations. Okay, so that's your most common application for Hamilton's equations, simply by using them on Hamiltonians. So in the next videos I'll be looking at the applications in physics, for instance circular motion, accelerator orbits and more.